right? Any doubts in yesterday's class? Yes. Yes. So let's start. In yesterday's class, what's the doubt? Huh? Atolls. Atolls, ठीक है. वैसे environment and little integrated topics है. Atolls are nothing but coral reef areas. See, there's a term called atolls. Yesterday I told you that if this is your ocean and this is the base of your ocean, that is bottom of the ocean, imagine there is a volcano which comes out and it builds out to be an island, but you have an island which is submerged. Okay? Now imagine that this island is submerged. Island is submerged. So if this island is submerged and it is not more than 200, 300, 400 meters deep, not more than 400 or 100 to 400 meters deep, right? Now in such a case, sunlight can penetrate through that water, right? So when sunlight can penetrate, now due to a symbiotic relationship between zooxanthellae and phytoplanktons. These are, one is an animal and other is a plant. These are microscopic organisms which you cannot see with your naked eyes. Between them there is a symbiotic relationship. Symbiotic means zooxanthellae will help phytoplankton, phytoplankton will help zooxanthellae. So they'll start to form corals. Corals are tiny species which are also called as polyps. Polyps means something which will float with the water. They cannot balance themselves in the water. Such kind of tiny species, they will come and start to deposit here. They'll make their home. Okay? Once they make their home here, they'll die. Their lifespan is not too long. They die. Imagine that they are dead. They release calcium carbonate. Calcium carbonate means nothing but your bone. They deposit that calcium carbonate. Again, on that calcium carbonate, imagine that these are calcium carbonates, the skeletons of the corals. On this, again, new set of species will come, coral reefs. They also die. When they die, they release their skeletons here. Likewise, you will see all of them start to come above the surface. Now this becomes an island. 200 meters or 150, 60 meters which has risen above the surface. Or sometimes just hardly sea level, sometimes the land will be below the sea level itself, hardly 5 meters, 6 meters. So you go to Lakshadweep, you'll find these kind of landforms. Maldives, yes. And Seychelles, yes. Mauritius, yes. So these are the landforms that you'll get to see. Now they'll have a unique shape. The shape is in the center part of the, see in the central part of the area. I mean to say, in the center, it has the ocean open, but around it you'll have a circle. A circle which is full of calcium carbonate and the life forms. Now, if this landform is in the form of a circle, this is called as an atoll, which is full of what? Coral reefs. Calcium carbonate के साथ होता है. Yes. I'll show you these atolls. वैसे coral reefs are of 3 different types: atolls, fringing reefs, and barrier reefs. All these 3 are based on the shape that they have. Atolls does look circular in nature. Barrier reefs will look like an arc. Fringing reefs, they just come out of the surface from one single side. I'll show you all 3 different types. This is an atoll. The circular area, which you get to see here, this is the surface, but in between what do you have? Water. If the shape of the coral reefs is this is called as an atoll. Majorly you'll get to see in Maldives. Zoom in and see. This is your this is an atoll. Length can be as big as the size of Chandigarh and as small as the ground of Punjab University. Yes, tourism. Significance is tourism and ecology. Ecologically, you'll find very unique species here. If coral reefs are there, it is an indication that they start to give food chain to that is the place where the food chain of the ocean starts. Small microorganisms will come and start to live in the skeletons of the dead skeletons जो होता है ना, उस skeletons में many animals will come and start to live there, and then they make their home. Like that, octopus lives in this part of the area. There's a set of species that you will get to see here, and they help each other. That is called as an atoll. But you also have barrier reefs. Like this, you have many atolls. ठीक है, एक नहीं है. You come to Lakshadweep also. This is Lakshadweep, right? Now let me zoom in. Atoll. So there is another type of coral reef which you will find the biggest coral reef in the world, which we call it as the Great Barrier Reef. This is called as Great Barrier Reef. यहाँ से लेकर for Australia, it is acting like a barrier. Look, this is your Australia. Now, any waves, any oceanic material, if it is coming, it has to first hit the coral reefs. So, coral reefs are considered to be the protectives for the Australia. And here, this is the biggest coral reef across the world, and you will find many number of small atolls, a barrier reef. यहाँ पे unique set of species you will get to see, and दुनिया का the diversity is very, very high. Very, very high diversity you will get to see here. Right? They are saltwater species. Corals are saltwater. They are not freshwater. And corals cannot live below 500 meters. They are only present in the top layer. If the temperatures are beyond 27-28 degrees Celsius, your corals will die. When the corals die, what happens? Yes. What is the term used for coral dying? Yes. Coral bleaching. Coral bleaching means the beautiful colors which the corals have, they don't have it anymore. Look, an original coral reef does look like this. You will have set of different species living in them. Colorful species. Coral bleaching means whenever you have high temperatures, they undergo stress. The species which are there, they undergo stress and they die. When they die, they leave all the colors and they look like this. Now what is this? It is the skeletons. Calcium carbonate. Only skeletons, no other animals that are there. ठीक है? So in totality, this is what is your coral reefs. 3 different types होता है. 1, see, if the shape is like this, you will call it as an atoll. If this is your island, and only on one side you get to see the formations of coral reefs, you will call it as fringing reef. And if suppose you have a continent here and next to the continent you have a wide barrier like coral reefs, this is called as barrier reef. That means there is barrier reef, there is fringing reef, and there is an atoll. It's just the shape, circular shape, a barrier, and it is fringing reef, right? So let's move further. Oceanography. Today we have to learn about the temperature of the ocean. Now this temperature can be studied, if this is Earth, it can be studied latitudinally. That means north to south and south to north. Latitudinally, what kind of temperature do you have here? What kind of temperature do you have here? This is one way of studying. And the other way of studying is, if I go deep into the oceans, imagine this is the depth. This is 0 meters of the ocean. And this is 6,000 meters of the ocean. So, as you go inside, what is the temperature that you are going to find? Now, this study is called as latitudinal temperature of the ocean. This also we'll study, and we'll also study this, right? So, the vertical variation of the temperature of the ocean. And before I move any further, any doubts in yesterday's class? Fissure type volcanoes can be acidic. It depends. In the volcanism chapter, I'll discuss in very detail. It's just day after tomorrow is volcanism chapter. I'll discuss. ठीक है? क्योंकि interior of the earth temperatures also you need to know, because I have to teach you the concept of conveyor belts and the linkage of the volcanoes there. So tomorrow end of the day or day after tomorrow, we'll have volcanism and we'll say bye to the oceanography as well. Right? So yesterday you had a brief idea about ocean topography. So today we'll start with horizontal and vertical distribution of the temperature, that is within the temperatures of the ocean, which this is horizontal and this is vertical. First, let's try to understand the vertical profile of the ocean temperature. Right? Imagine this is your ocean. ठीक है? Right? This is your ocean. And from here, if you are going towards the depth, what happens to the temperature? Will it decrease or increase? Will it decrease consistently? No. Why? Why not consistently? Basically, where are we getting the ultimate heat of the earth? Ultimately, where are we getting our heat from the earth? It's from the sun. Will the sun be able to pass through this water towards the depth? No. So that's why until the sunlight is there the temperatures will be warm, and beyond the layers of the sunlight, the temperatures will be cold. So in totality, this vertical distribution, it can be studied at various places. So this vertical distribution, before I move further, let me show it to you here. See, 1. Let's take this earth and rotate it like this. If I consider the earth to be like this, I slice the earth into 2 halves and I'll take this part of the earth. What is the latitude which is present at this? This is 90. Right? This part of the area is polar area. And this part of the area is again polar area, 90. This is also 90 degree north, 90 south. This part of the area is, this part of the area is near to the equator. Can I call this as 45, and this is 0? Right? As I am increasing the depth, the depth profile in this part of the region will be different from the depth profile of this region. Right? You agree? That means I'm going to take this as an ocean. This is 90, near to the 90 polar regions. I'll mark them as like this. These are polar areas. And then these are equatorial areas. And this is subtropical and subtropical areas. Right? Now this temperature profile is completely different. Whatever you get to see at the poles, you may not get to see here on the surface. So what is the temperature at the polar region on the surface? Is it cold or warm? Cold. At the equator, comparatively warm. See, the natural laws which says that the warm water would like to move towards the cold water and the cold water would like to move towards warm water. Why? To maintain an equilibrium. So the tendency is always the warm water would like to move towards the cold regions and the cold water would like to move towards the warm regions. Again, the warm water tendency is to rise. The cold water tendency is to sink, because cold water will be little heavier, warm water is little lighter and it tries to evaporate fast. So that's why the movement of the warm water is comparatively slower. It moves against the gravity. Warm water tends to rise. It is beating the gravity and moving away. But cold water is moving under the influence of gravity. So that's why same concept is also applicable to the air. Warm air moves slowly, warm air moves slowly. Why? Because warm air to rise, it has to move against the gravity and rise. Cold air, it is moving, sinking, and it comes under the influence of gravity. Right? So in totality, this is how the water would like to move on the surface. But at the bottom, let's try to understand. See, the entire ocean can be divided into 3 layers. This is the top layer. Then you have an intermediate layer. And this is your bottom layer. Right? You can also draw the diagram like this, because in your books and all, this is the diagram that is drawn. Imagine this is your ocean. See, this is 0 meters, this is 800 meters, this is 1500 meters, and then 2000, 3000, 6000. That means I am increasing the depth in this direction. Right? Now, if I am going to draw the temperature scale here, this is the temperature scale. Imagine if suppose, just try to understand this. This is 27 degrees Celsius. This is 25. Like that. This is 0, -1, -3. Like that. This is 5, 7, 9, 15, 17, 20. Right? Suppose at 0 degrees, if I say the temperature is 27, that is here. 0 degrees latitude. This is your this is meters. This is meters. At 0 meters, if the temperature is 27, that means my point is here. At 0 meters, that is at the surface of the earth, if the temperature is 15 degrees, that means this is the dot. At 800 meters, if the temperature is 5 degrees Celsius, this is how it is marked. At 800 meters or at 1500 meters, the temperature could be 0 degrees Celsius. Now, the graph does look like this. That means as I am increasing the depth, the temperature is also reducing. So here, let's try to understand how the temperature varies from 3 different layers. Now, we are going to study this vertical, vertical distribution of temperature. In this vertical distribution of temperature, I told you there are 3 layers. First layer, second layer, and third layer. First layer is called as top layer, second layer is called as thermocline, and the third layer is called as deep water. Right? Bottom ocean. So let's see. Or else this way also you can mention same thing. This is top layer, thermocline, and this is bottom ocean. Right? This is bottom of the ocean. Now, how many meters is considered to be the top layer? It is up till, if this is 0, it is till 500 to 600 meters. Now, intermediate layer is 1000 meters to 1200 meters tak bhi ho sakta hai. Right? That's the height. And in your NCERT books, it is given as up till, this is considered to be till 1000. So let's also take that this is 1000 meters. Okay? Now bottom is, this is 6000 meters. Clear? So let's try to understand how the temperature drops. So imagine the temperature in the top layer. So this is top layer. This is the intermediate layer, and that's the bottom layer. So on the top layer, the temperatures can be pointed on an average. It could be 25 degrees Celsius. Okay? 25 degrees Celsius. I'm talking about any average temperature except for poles. Poles में क्या होगा temperature? 0, 1, 2, 3 होगा. But when I go to 50 degrees north latitude, what can be the temperature there? 50, 60 north. It can be 10, 15, 9. But I am going to equator area. Temperatures of the ocean can be 20, 25. But in subtropicals, cyclones can be there, 27. So the diagram which I am going to draw, this is a very important diagram, and it will help you to understand the oceanic depth temperatures in detail. And that has a relationship with multiple factors. So ध्यान से समझ लेना. कोई doubt है तो you can ask me. See here. What's this? The surface water, on an average, there is good availability of sunlight, so sunlight can pass through this part of the top layer, maybe until 200, 300. So here, the temperature drops like this. Here the temperature is somewhere around 25, and the temperature may not drop much. Okay? The temperature could be dropping to 15 degrees Celsius as soon as you go up to 500 meters. But from 500 meters to 1000 meters, the temperature can drop drastically. Okay? How much? So let's draw it in a better way. Here 25, 27, here the temperature could be only dropping till 7 to 6 degrees Celsius. But as soon as you go into the second layer, that is thermocline layer, here the temperature dropped till drastically. And beyond this layer, you will find the temperature to be dropping at a stagnant. It is more or less the same. Okay? It is more or less the same. So this layer is called as and look at this top layer is only up till 500 meters. Can I say there is availability of sunlight? Right? This is called availability of sunlight. Next, second, thermocline. What is this? Why is this called thermocline? Thermo means temperature. Cline means variation, not decline. Okay? It can be incline and decline. Cline means variation. Try to understand. Decline matlab niche. Incline, it can be inclined in this manner, inclined in the bottom manner. There is large scale variation in the temperature in the thermocline region. It is not just decreasing, it can also increase. For example, you go to the polar region. Let's consider the graph that I am going to draw is of polar region. In the polar region, what are the temperatures of the surface? 0 minus also it is. Now, in fact, as you go to the bottom, the temperature increases. Right? It is like this. The temperature here increases and then joins like this. Got it? You are getting to see. In fact, from -1, it is becoming 1, 2, 3, 4, and here the temperatures are increasing and joining the line. This is polar. So for the polar thermocline, in fact, the concept of thermocline is not much valid to the polar regions. Is there much variation like the variation that you got to see here? Right? In fact, the concept of thermocline do not apply to the polar region, because as you go towards the bottom, in the thermocline region, the temperature actually increases to an extent. Right? We say that thermocline in the actual format may not function at polar regions. ध्यान से याद रखना, why it is not functioning, I'll tell you little later. Right? So, if I have to draw this, can I draw it like this? This is polar region and this is subtropical, and temperature for the equatorial regions, temperatures are actually less as compared to that, and this will be equatorial region. This is top layer, intermediate layer, and this is bottom layer. Got it? So this is how the variation will be there. Now come back. Why there is drastic decline in the temperature of thermocline? Because absence of the sunlight. Right? Therefore, now come to the bottom layer. In the bottom layer, the temperatures are always cold. It is the coldest region of the interior of the earth, interiors of the ocean. And this bottom layer, the density is higher. If I put a human being at this particular place, and this is point A, and I am taking this human being to this layer. In the first case, that is, this is point A and this is point B. At which point the human being will be experiencing more weight? Obviously A. That means, can I say that if anything which is there at the bottom, they'll experience more weight? That means density of that material will be high. Pressure is very high here. That means the pressure at the water का pressure जो है ना, at the bottom is always high. Density is always high of the bottom water. Density of the water is always high as compared to the column above. You take a particular column like this, any column you take, the density is always high here. As you move little upper, the density becomes lower. This is something which you need to remember for understanding the further topics. Right? Okay. Now this is nothing but your distribution of the ocean water temperature in the vertically. So if there is a variation in the temperature, if there is a variation in the temperature, will it not lead to the variation in the salinity? Will it not lead to the variation in the density? Suppose, just imagine, I have a bowl of water and this is 1000 ml and I have 300 grams of salt in this. I also have a bowl of water which is having 1000 ml of water and I have 300 grams of salt in this. Now I have decided that I am going to heat this. I can heat this through the process of sun's heat also. When I am heating it, what happens to this water? Evaporates. So let's imagine that there is evaporation that took place and it is leading to the formation of the clouds. Right. And how much evaporated? Let me call this 200 ml evaporated. How much we are left with now? 800. Currently the resultant is 800 ml. How much salt is there? How much salt is there still? Why 300 grams? Because evaporation takes place only of fresh water. The fresh water component will be evaporated and the same 300 grams will be there in this. That means from 1000 ml, 200 got evaporated, the resultant is 800 ml. Even in the 800 ml also you have 300 grams of salt. Now tell me, if there is good amount of sunlight and it is leading to the evaporation, is it increasing the salinity or decreasing the salinity? Salinity increase, because here how much water I am having currently now? I am having 800 ml only. In this 800 ml of water, in finally resultant is 300 grams of salt is there. Here I am having 1000 ml of water and 300 grams of salt. Who is more saline? I'll give you a glass of water of this to you and a glass of water of this to you. The time when you drink this water, you say that this is saline. Namak ka pani hai. So usually, wherever you find evaporation, there the salinity should be. I'm telling, the salinity in general should be higher. But if there is evaporation, it will also lead to rainfall. Right? The direct relationship, I'm talking about the direct relationship between evaporation and the salinity is, if the evaporation is more, salinity will be more. One factor. Other reason for the salinity of the ocean is that if suppose there is a river, look at India. You have Ganga river floating here, Brahmaputra, Mekong. Where are they coming and joining? Into the Bay of Bengal. For the Arabian Sea, in the Arabian Sea, it is only one river, that is Indus. Bichara ye Indus na, while it is moving, it actually passes through the desert of Pakistan. And the total volume of the water which comes into the Arabian Sea is less. River water is fresh water. Oceanic water is saline water. If I am adding Mahanadi river, I am also adding Godavari river, I am also adding Krishna river, Kaveri river. Now imagine this is a bowl, and this is also a bowl. Only some fresh water is getting added, but here more and more fresh water is getting added. So who will be more saline? My Bay of Bengal or Arabian Sea? Arabian Sea will be salinity. Sunlight तो same है ना यहाँ पर. Arabian Sea and Bay of Bengal will receive more or less the same amount of sunlight. In spite of having good amount of sunlight, which will lead to evaporation, right? But there is another factor called influx of water. That is, fresh water is adding to it. So that's why your Bay of Bengal is not much saline. Right? This is more saline. अब नमक का पानी जल्दी गर्म होगा या fresh water will get heated fast? That is, will the fresh water get heated fast or this water will get heated fast? Obviously, the fresh water can gain the temperature very faster. So that's why more cyclones are formed here, because 27 degrees Celsius can be easily achieved in the Bay of Bengal. But whereas salty water hai, dense hai, they cannot get warmed up that easily. So that's why less number of cyclones are found in this part of the region. Okay? I'm talking about the total number. But IPCC report says that in the last 20 years, the frequency of the cyclones in Arabian Sea increased. Frequency. Earlier the frequency is maybe साल में 5 cyclones या 6 cyclones होता था, 5 or 6. But the frequency is now it is 10 to 12 they have come. But in Bay of Bengal it can be more than 15, 20. The total number of cyclones are more here, but in the last 20 years, the frequency of cyclones increased. I hope you got this. So there could be multiple factors which will decide what is the salinity. It is not only the temperature that is going to decide. So blindly ये याद मत करना यहाँ पे टेम्परेचर ज्यादा है तो सैलिनिटीज क्या होना चाहिए, ज्यादा होना चाहिए. It's not like that. There could be other factors like influx of water that can influence. So whenever there is a question on salinity, 2 seconds सोच लेना. That is it only temperature? No. Are there any other factors that you need to understand? Right? So can you remember this? That means here it is temperature is 15 degrees Celsius, but here it is 4 degrees Celsius, and here it is 3 degrees Celsius or 2 degrees Celsius. In totality, this is the bottom ocean temperature of the vertical distribution of the ocean. Now, yes, that's a very good question. We have learned about middle oceanic ridges, right? These are middle oceanic ridges. Now, wherever these middle oceanic ridges are there, they will influence the temperature of the local region. Only local region, not the entire ocean, but that part of the local region they can influence. Right? But this particular activity we are going to study in the concept of conveyor belts. What are these conveyor belts? I'll explain to you in some time. Are you clear till here? Any doubts? और कुछ पूछना है, इंटरलिंक करना है किसी टॉपिक से? You're true. For example, he says that, sir, this is Atlantic Ocean. In the Atlantic Ocean, this entire belt will have middle oceanic ridges. But the width of this middle oceanic ridges is very narrow. In this entire belt, there is a small local variation. Only local variation will be there. राइट. लोकल वेरिएशन मतलब 10 किलोमीटर तक वहां पे थोड़ा पानी गर्म हो सकता है. हाउ डू वी नो? ओनली लोकल वेरिएशन. But how do you know? Have you ever been to the bottom of the earth? No. But how are we able to calculate all of those? Just submarines, no doubt. See, today, oil. कल वाला क्लास अटेंड किया आपने? नहीं ना? किया? ऑयल कहाँ पे मिलता है फिर? Continental shelf. Oil is hardly found at a depth of not more than 200 meters. Scuba diving also 100, maximum 30 meters, 40 meters. Atolls, आपने पूछा है ना? Scuba diving, it is done only in atolls. Human cannot survive below 70-80 meters of the earth. It is so much of pressure, your eardrums will get bursted. Maximum depth that you can go is 70-80 meters or 100 meters. Beyond that, you need to go through some vehicles. Have you heard of this Titanic? Last year एक incident हुआ था. There is a tourism company that wanted to create a tourism to the deep ocean water, right? And that company created a submarine, or it's a pod. Pod कहते हैं. Pod is nothing but a small submarine. Through that, they want to take them to the bottom of the ocean of the Atlantic, which is present at the 3,500 meters or 4,000 meters. They literally want to show them the ship wreckage of the wreckage is the broken ship of the Atlantic. So they took the CEO of the company and the top brass of the company went bottom, and they got struck in the plantations that were grown in the Atlantic ship, that is a Titanic ship. All of them lost their lives. Okay? So today we have the technologies. Even I want you to go home and study about Samudrayan mission of India. Okay? It's a homework for you. Anyone know about Samudrayan? Studied? What is it? See, India's target of the 2023 and 2024 is that we wanted to send a human into the space, and we also wanted to send a human into the bottom of the ocean, that too at 6,000 meters, right? Through equipments, through proper safety measures. And India is working on that. That is Samudrayan mission. This can be asked in your preliminary examination as well. Now, what is a mission of human sending into the space? If this is Samudrayan, what is that? Gaganyaan. Okay? On one side Gaganyaan, other side Samudrayan. So a preliminary statement can be there. Gaganyaan and Samudrayan are aimed to put the man into the space and the deep ocean water. Right? So yes, local variations can be there, no doubt. Yes, can be there. Yes, you are true. All these conditions will be there at the bottom. I'll discuss that after 10 to 15 minutes. Right? Now, Shaurya's question is that, sir, look at this middle oceanic ridges. Will there be not high variation of temperature in this part of the area? Yes, hardly for 20-30 meters ka distance jo hai na. Water is continuously moving. It is not stable, no. Had if it is a stable water, it will get that heat immediately. But water is continuously moving. So at that temperatures, at that bottom, it will lose the heat very quickly. So that's why there is not much of variation in the temperatures at the bottom of the ocean that you can get to see. Right? Okay. हाँ, गल्फ ऑफ अलास्का वो मैं करंट्स के टाइम पे डिस्कस कर लूंगा. देयर इज अ प्लेस कॉल्ड गल्फ ऑफ अलास्का. इट इज एट दिस प्लेस. इन दिस प्लेस द वाटर डू नॉट मिक्स. ठीक है? Literally you will see two different oceans, they are not getting mixed. I'll explain why is that. Now look here, if this layer is thermocline with respect to temperature, when there is large scale variation in the temperature, if suppose we are studying salinity, even for salinity also there is a top layer, there is an intermediate layer, there is a bottom layer. Now for the salinity, we'll call this as a layer by the name halocline. Because if there is temperature variation, it will also lead to salinity variations, it will also lead to density variations. So this is also called as halocline with respect to salinity. Right? Yes. Now, yes. See, with respect to the density, this is also called as, anyone who would like to name? It may not be visible there, that would be the better area. Okay? Please mind the camera, it might hit you. Yes. So, with respect to density, what is this called? Anyone? I told the same part of the area, it is called as halocline for salinity. With respect to density, what is it called? Pycnocline. Pycnocline. So let me show it to you. So this is how you'll get to see 3 different lines. Right? The same thing. Look here. This is thermocline. But salinity line is not the same. As you increase the depths of the ocean, the salinity is increasing. The density of the water increasing. Right? I hope you are able to get this. So the first concept that we have learned, as we are going to increase the depth of the ocean, on one side the temperature is decreasing and then the temperature is decreasing drastically. We call this as thermocline, and at the bottom of the ocean it is only 4 or 5 degrees Celsius. Now let's try to study the concept of salinity with respect to the vertical variation. Now imagine again. So I'll compare all of these 3. This is your bottom of the ocean. This is the ocean profile. This is 0 meters. This is 6,000 meters of your ocean. And this is the surface water. So this is your top layer. What is the depth? 500 meters. And this is your 1,000 meters depth of the ocean. Right? This is the bottom. Now let's try to study with respect to salinity. Right? When it comes to salinity, where do you find the ocean getting evaporated more? At the top, at the intermediate, or at the bottom? Top. Right? Chalo. एक छोटा सा analogy let's try to study. Imagine this is a bowl of water. Again, in this bowl of water, which is 1000 ml, मतलब 1 लीटर का पानी है ये, और I have put somewhere around 300 grams of salt. I started to heat this. I can heat it in various ways, right? I can give a radiation heat. I can also give a thermal heat, nothing but gas stove पे भी गर्म कर सकता हूँ, और मैं धूप में भी रख सकता हूँ, that is nothing but radiation heat. Now imagine I am evaporating 300 ml out of it. ठीक है? I have evaporated 300 ml of it. Whatever the evaporation that takes place and they go into the atmosphere and form the cloud, this is fresh water. Only the fresh water component of it will go and evaporate. Now rest of the 700 ml, how much salt is there? Is it not saline? But earlier in this water also there used to be salt, which is equally distributed. Now all this salt, where it will go and deposit? At the bottom. Why is it going to go and deposit at the bottom? Because it becomes heavier. When it becomes heavier, it is going to get deposited at the bottom. That means, is this bottom water more denser? Bottom water का density ज़्यादा होता है. Surface water का density कम होता है. क्यों? क्योंकि salinity कम है. Right? So in totality, when you look into the salinity concept, see, salinity at the surface is comparatively less, and then it will increase here, and it is more or less the same. Is it not exactly opposite to the temperature line? your temperature is like this, but your salinity, it is more or less the same in the top layer, then it is increasing, then it is like that. So with all of this, we'll study them in the further time period. Water density को pycnocline कहा जाता है, PICNO भी लिख सकते हैं, PYCNO भी, both are same. See, spelling से कोई difference नहीं है, you can also write like this, PI also, PY also. Shavindra Singh writes it as PI, but chalo, NCERT PY. Clear with this? Now let's try to go and study the entire water movement. See, we are going to study the movement of the water. Now this is one of the most important concepts. Now how the water moves in the atmosphere, how the water moves in the ocean. Right? So watch this video. Let's take a minute time. Our water in the ocean moves in a particular path. And it has a very unique properties. Very unique properties means they will not change the direction until and unless something major happens. If suppose they are changing the direction, you sitting in this classroom will experience that. Maybe in the form of rainfall, maybe in the form of humidity, or some other major changes. Okay? Especially climate change also. How many of you have heard the concept of El Nino? La Nina? Indian Ocean Dipole? कहीं ना कहीं सुना होगा ना? El Nino, newspapers and all. El Nino, La Nina and other concepts are associated with this ocean water. ठीक है? Plus, this movement of the ocean water, they are dependent upon multiple factors. The ocean bottom होता है ना, bottom topography के ऊपर. I mean, is there a mountain? If it is, this water goes and hits to the mountain and then sinks. And within the ocean, there can be lakhs and lakhs of mountains that you got to learn in the last 1 week. Right? So, why are we supposed to study this movement of the water? Why? Volcanism समझने के लिए, चलो ठीक है. But why should we study this water movement? How is it going to help us? Transportation, ठीक है. See, water can be divided into two forms. The ocean water, number one. Surface ocean water and bottom ocean water. Surface ocean water means surface ocean, only top water. The top of the ocean which is there, which is considered to be 10%, the top water is only 10%. Rest of the 90% is this water, which is ocean bottom water. Now let's try to understand how the water on the surface moves, how the water in the bottom moves. Right? Whatever the circles that you are getting to see, all these are considered to be the water which is moving at the bottom. ठीक है? These are ocean water which is moving at the surface, that is bottom. Okay. Look here, this part of the water is considered to be surface water, and this part of the water is considered to be bottom ocean. Right? And remember one thing, our surface water, which is only 500 meters, top of the ocean's 500 meters, will not mix with this water. Why are they not mixing? Because there is a layer called thermocline, it is not letting, there's density variations, there is also salinity variations. Right? All the movement of the water, this at the surface, the total volume when you take, it is only 10% of the total volume of the water, and this is 90% of the total volume of the water. Thermocline का है, but in general, near to 10, near to 90. ठीक है? 90% of the total water that you get to see, I'm talking about 90% of the total water which is there, is bottom ocean water, right? And this is only 10% of water. Let's call this as 80 and let's call this as another 10. But we give so much of significance to this. हमने याद है, while we were studying about this earth, I told you that in the atmosphere, 90% of your syllabus is present here and 10% of the syllabus is present here. What is this 90%? Troposphere. Likewise, this 10% is outer atmosphere. Likewise, within your oceans, 90% of the syllabus is here and 10% of the syllabus is here. But every year, one question will be there from here and 2 to 3 questions from here. Right? Cyclones कहाँ बनता है? Cyclones are formed here. Right? Storm surges? Top layer. Now, why do we have to study this layer? Yes. See, we are supposed to study this bottom layer because this is the layer. It will decide whether you have to live or whether you have to die. That is the impact of this. See, the video which I have shown you, it is of bottom ocean water. And you know, this bottom ocean water moves under certain different characteristics. Surface ocean water क्या है? अगर हवा इस तरफ जा रहा है, ठीक है, let's imagine if the wind is moving in this direction, the water will also move in this direction. If the wind is moving in this direction, the water will also move in this direction. And whenever that wind or water, whatever it is moving, it has 3 different things. Tides, currents, waves. Right? Tides, currents, waves are present here. Right? But this ocean water bottom, it moves like a tortoise. It moves very slowly. See, this ocean bottom water, as and when it starts to move slowly, it takes near about few thousands of years. It takes near about few thousands of years to come back to its same position. Now, the video which you are watching is ocean bottom water. I am not talking about surface water. The water to come back to the same position again, it takes how many years? Thousands of years. But how do we know that it is taking thousands of years? स्पीड कैलकुलेट किया जा सकता है, बट लेकिन कैसे कैलकुलेट करोगे? इफ आई एम आस्किंग शौर्या, प्लीज गो एंड कैलकुलेट द स्पीड ऑफ दिस वाटर एट विच रेट इट इज मूविंग, हाउ विल यू कैलकुलेट? चलो मैं पूछता हूँ 1 मिनट में ये वाटर कितना मूव हुआ, बट व्हाट इज द इक्विपमेंट दैट यू आर गोइंग टू यूज? He says convectional currents. But anyone? Do you have any equipment? Chalo, you are a district magistrate and you are posted into the ocean bathymetry mapping of the Indian Ocean. And you are asked, please calculate the movement of the water speed in the Indian Ocean. आप एक IAS officer हो. Then आप बोलेगे, sir, ready sir, थोड़ा मदद कर लो. ठीक है? How is it calculated? नहीं. See, what do we do is, you heard about the nuclear blasts that are done by USA, Russia in the erstwhile time period, right? They have done thousands and thousands of nuclear blasts that are done, right? Imagine if USA has used, imagine that USA did a nuclear blast here in this part of the ocean. The water that is present, will it not be nucleated? It is having radiation, right? Now, as Shaurya says, I'll go and measure for 1 year how much movement of the speed is there, right? So today we have a technology to measure the nuclear radiation in the ocean water bottom. So imagine that this water which is exposed to the nuclear water blast under the ocean, I'm talking about thousands and thousands USA has done. India ke upar, India has tested its nuclear weapon in which year? Pokhran 1. Second thing, Kargil time period also we have done. First one is during the Indira Gandhi time period, right? Smiling Buddha. Second one we have done again at Pokhran itself, Shakti Vayu, for which all the foreign countries have put sanctions on India. We have done just 2 or 3. How many US did? US did thousands and thousands of tests. No one is questioning US. It is always they do the things and then they come to us and they say that chalo chalo ye mat karo, oh mat karo, don't do this, don't do that. So we are not here to learn whatever they teach to us. They are already a developed nation. They have everything to eat, everything to feed. They have extravagancy. अगर जूता खरीदना हो तो 10 टाइप के जूता पहन लेते हैं. इंडिया में at least 2 to 3% of the people do not even wear slippers because they cannot afford. We cannot put India at par with US and look out for the measurements at par. So we are we started our development late. They have done it, but nevertheless, these nuclear blasts which are taking place, as the water moves, we start to measure the movement of this particular nuclear radiated water which is there. And second thing, as he rightly said, volcanoes. You know that within the bottom of the ocean, you have thousands of volcanoes which are there. Now, each of this volcano, don't you think that it will also give out some kind of nuclear material which is coming out? If suppose Indian Ocean is there, this material is also throwing out nucleated material, radiation bhi hota hai unke andar. So we calculate that particular radiated water at what rate it is moving. And we found out that, it is moving at such a slow rate that to come back to the same position, it is going to take at least 2,000 to 3,000 years. Now, IPCC, current affairs, it says that this water is moving at a slower rate as compared to last 100 years mein jo rate tha. Now, why? It is because there is a deep linkage between the movement of the ocean water here and the carbon emissions that you are doing. Maybe today morning you took a brush and you brushed. For production of the brush, somewhere in the industry that has burnt carbon. The vehicle that you use, it is burning carbon. And as well as the room in which you are sitting, we are burning electricity that releases carbon. AC releases carbon. In totality, we have contributed the temperature of the ocean water bottom. Take a bottom ocean water temperature jo hai na, it is increasing. Because of that, it says that the ocean water is moving at a slow rate. Right? In the exam, the examiner can ask you, what is the impact of the bottom ocean water movement and its implications on the climate change? See, let's come to the basics again. Why should you be worried about the water moving at a slow rate? Why does anything on the earth moves first, be it wind or water? क्योंकि कई जगह गर्म पानी है and दूसरी जगह ठंडा पानी है. The water, hot water would like to move towards the cold water. This mixing is called as equilibrium. And this equilibrium, you need to understand. It is also there in the air because at some place the temperature is high and the air above is high. Here the air may be cool. The warm air and cold air would like to move towards each other and maintain an equilibrium. Suppose same is the case. If I am changing the temperature, don't you think that the speed of the water will change? And that is what is happening. Now, how did you change the temperature of the ocean water bottom? One, carbon emissions. Carbon emissions means you are increasing carbon dioxide. How is carbon dioxide which you have increased into the atmosphere is going and impacting that? कोई relation सोच सकते हो? देखो, if suppose you are increasing the plantations in the bottom of the ocean, plants take what? Carbon dioxide. They give out what? Then what is the relationship between these plants and the ocean water bottom? Mining. Deep ocean drilling. ठीक है? You are mining the oceans. India is also mining, right? Where is it mining? मैंने कल homework दिया था. Afanazi Nicotin Seamount. So when you go to the bottom of the ocean and you start to mine, there might be areas where greenhouse gases can be there. Now these greenhouse gases which are there, they try to emit outward and the carbon dioxide is released. Like this, we go and mine. We don't send human beings to the bottom, but we send drilling machines and they are drilling. There can be large amount of greenhouse gases that are present here. You puncture it and you don't know how to close it. Like this, USA, Russia, and developed countries, they have put thousands, near to lakhs of holes in the bottom of the ocean. Continuously there are bubbles coming out from that, and that bubbles are nothing but methane. Methane is a gas which is considered to be greenhouse gas. Now those gas bubbles which are there, we are not in a position to close that. We do not have the technology. Don't you think that they are the one who are creating the problem here? Now they say that let's make some rules and regulations. If anyone wants to mine the ocean, that let's now keep these rules and regulations. They have to do it. They have done whatever they have to do it. Now they point out rules to the developing nations, maybe someone who wants to mine newly. So that's why India always says, beta, problem jo hai na climate change ka, sabka same hai. Problem is, it's a problem to everyone. Lekin responsibility jo hota hai, that if you are a developed nation, you share the responsibility more. मतलब आपका responsibility ज़्यादा है, मेरा responsibility कम है. This is called as common but differentiated responsibilities. So India feels climate change solutions are discriminated. Our solutions to climate change across the globe are discriminated. They put, for example, a poor person who is there. ठीक है? Temperature गर्म हो गया. How much? In summers, the temperature is 50 degrees Celsius, it reached in Delhi. Now let's imagine a poor watchman who is working day in, day out at the gate. And evening he'll go to his home and he do not have any AC at his home. Cooler bhi mushkil se mushkil, he can afford that. And he has two kids going to the school and coming back. He is a poor person. Now there is another person who comes to Mercedes and attend the UPSC classroom. I don't want to name. They come to the Mercedes and sit in the Mercedes and attend. They go back and then they go back and then sit into the AC rooms. और AC room में रात को 12 बजे मैसेज करते हैं, सर इसका PDF दे देना मुझे. I am not getting it online. Right? So this particular person can also afford ACs. For him, does the climate change impact? Not much. This person can add one more AC. Now imagine that person is a US person. US is a country like that. So here, the poor countries, that poor person imagined to be a developing nation like India. Now that particular nation cannot grow in this era of new climate change and new oceanography technologies. Until and unless you don't have this technology, right? So you cannot tap the potentials. Right? That is one of the reasons why you have to study, because we do not know what kind of impacts it is going to have. इसीलिए Government of India, in the name of Samudrayan Mission, we are going to explore the bottom. Now, first what do is, we'll try to understand how the movement of the ocean water taking place at the surface and then at the bottom. Right? Okay. This is the movement of the oceans. Movement of the ocean water. मतलब ocean का water move कैसे करता है? There are three ways in which the ocean water can move. First one, tides. Second one, waves. Third one, currents. These are the three ways in which the ocean water moves from one place to another place. So yesterday itself I told you the difference between what is a tide, what is a current, and what is a wave. Now first, let me try to ask you what is a current. Okay, if not current, what is a tide? Rise and fall of the water. That means, if suppose this is an ocean, if suppose the water does rise and they fall, again they rise, they fall, this is called as tide. Why they rise? There is sun and there is moon, both are trying to pull. ठीक है? This is the direction in which they are trying to pull, and they pull sometimes. That is why you got, when it comes to waves, again, if this is an ocean, will the water move in the waves? Water moves in circular motion. If suppose there is a wave, it is not the water which is moving from one place to another place or long distances. In fact, the energy is the one which is moving from one place to another place. It is not water. Water का movement क्या है? Water movement is they rise, they fall, and then they come back. Again, यहाँ का पानी it rises, it falls back, and it comes back. That means the water is moving in a circular motion. Now, till what distance the water moves in a wave? 1 kilometer, 2 kilometer, 500 meters, 30 meters, 10 meters. Energy का intensity पे depend करता है. Very good. But what is the length of the wave that you ever get to see? How many of, बहुत सारे लोग कल हाथ तो उठाया था, beach you have been. ठीक है. Water gets displaced till what distance in a wave? Huh? Man-made waves also, but normal wind-related waves. Maximum 20 meters, 30 meters. That's it. पानी 20 मीटर आगे जाएगा, फिर वापस आता है. 20-30 meters. Except for one wave which is called as swell wave. Swell waves जो होता है ना, very very dangerous. You might have heard about few people going into the beach and they got struck there. It is because of rip waves and swell waves. There are two different types of waves that are considered to be very very dangerous. Swell waves जो है, when they come, they destroy the coastline. Rip waves जो है ना, they pull you back. I'll explain this after some time. Right? But waves mein, it is only the energy that is traveling. Make sure to remember this. In the waves, the water move forward and they rise, they fall and they move backward. They move forward, they rise and they move forward. They fall and they move backward. Move forward, rise and fall and backward. This is the movement of the wave. If I am speaking, am I not sending the sound waves? And these sound waves are coming and vibrating your ear. That means, ये हवा में it traveled. In fact, this travels as a wave. It moves like this. My voice is moving like this. This is nothing but your sound wave. वैसे ही, there are waves in the ocean which moves the water in circular motion. That means, the water always moves in this way. But when it comes to the coast, what happens? When it comes to the coast, what happens to the wave? Coastline damage हो सकता है. Let's try to understand. चलो. Imagine a person is standing here. Right? The wind is moving in this direction. In what direction the wave moves? This is how the wave moves. Wave is nothing but transfer of energy. The energy from here will be sent to here. But the water moves in this direction. यहाँ पे पानी इस circular motion में move करता है. But wave might come here. Right? So, again, you will have a circle here. The water moves in this direction. Suppose if you have a drop of water, this drop of water moves in this direction. Again, it moves only in circles. In fact, यहाँ का जो पानी यहाँ पे reach नहीं करता है, ध्यान रखना, in the waves. So, in totality, the same wave, when it comes to the coastal area, the wave or the energy of the wave breaks down. But when does it break? When there is a condition when the wave breaks. What is that condition? The condition is, what is wavelength? स्कूल में पढ़ा है ना? यहां से लेकर यहां, this distance is called wavelength. ठीक है? There is a condition when the water that is traveling, or the energy that is traveling in the ocean, not the water, the energy that is traveling, it will break when द वेव लेंथ जो है यहां से लेकर यहां, वन डिस्टेंस इज कॉल्ड एज वेव लेंथ. दिस इज कॉल्ड एज ट्रफ्स एंड क्रस्ट. आई होप एवरीवन नो व्हाट इज दिस. ट्रफ और क्रस्ट. ट्रफ एंड क्रस्ट. ठीक है. सो वन ट्रफ एंड वन क्रस्ट इज कंसिडर्ड टू बी, दिस इज कंसिडर्ड टू बी अ वेव लेंथ. ये डिस्टेंस को वेव लेंथ कहते हैं. इफ सपोज द डेप्थ ऑफ द ओशन, remember this, if the depth of the ocean is not more than 50% of the wavelength, if suppose this wavelength is 20 meters, if the depth of the ocean is less than 10 meters, then the wave breaks. At that point of the time, the water will come and hit you hard. The energy is released. Right? I hope you got it what I am trying to tell. दोबारा मैं समझा देता हूं. In a wave, look, waves, it is nothing but from one place to another place. Now it can be, this transfer can be, it can be a sound or it can be hydrowave. Hydrowave मतलब पानी में. So it can be anything. ठीक है. You should not always take waves means only waters will have waves. Next, these waves have a special characteristics. Look here. They move forward and they rise. ठीक है. They fall and they move backward. And this is how the movement of the water takes place. That means they rise, they move forward, and they rise, and they fall, they move backward. पानी का movement ऐसा होता है. Next, look at this. Next set में यहाँ का पानी again they are moving forward and rising. Here the water will come back to the same position. They move backward and falling. Right? So in this manner the water is always moving in circular direction. So this is a wave. If suppose this is a beach, this is your ocean. Imagine the depth here is 10 meters and the wavelength is from here to here, it is 20 meters. 20 meters is the wavelength. This is 20 meters, the wavelength. So look, here the wave energy which is there, the energy breaks as soon as the wave comes to this point and it splashed the water onto the other side. When does this happen? When the wavelength and the depth ratio is 1, मतलब half ratio minimum होना चाहिए. Right? Now first suppose, when do you get a strong wave? When do you get a strong wave? The wave will be stronger when ये जो depth है बहुत कम है लेकिन wavelength जो है very big. If the wavelength is 30 meters but your depth is only 2 meters, then the wave is going to be drastic and it will throw water into the interiors of the land. right? So these fellows who are standing, oh, they keep on rushing. They wanted to have a holiday, but they'll have a disaster there, right? Or again, wave का characteristics क्या है movement of the water में? They rise and move forward. This is first part of the wave. The second part of the wave is they fall and backward. So let's imagine that this person is having a good day at a beach. This person do not know that wave is having a characteristics of one, this wave, it rises and moves forward, but this wave is having a backward movement also. जब भी backward movement होगा, you have to realize it, and then what you have to do is simply jump. When you jump, you can beat that backward movement. If you are not jumping and you would like to stand and move forward, it will take you backward. ठीक है? So it is always advised whenever the wave comes, you have to jump, so that the impact of the backward movement means this water will again move backward, right? So in totality, the wave will make the water move like this. One, it is rise and move forward. It is fall and move backward. Got it? These are your waves. Waves are different, water movement is different. Got it? Chalo. No. Depth. The place where it is going to touch. Continental shelf जो है ना, that continental shelf पे क्या depth है? Always energy is released at the continental shelves, right? So if the depth of the continental shelves with that of the wave length which is there. Now why are waves created? Wind is the reason. Wind is the only reason. Second one is rotation of the earth. These are the two aspects. Now let's come back to the concept of tides. Are you clear with this? Yes. Heat. Now look at his question. It's a very good question he asked. Sir, at the deep ocean, there is a methane gas leakage that took place. Now he says that, sir, deep ocean water mein, there's not much of temperature which is there. Why do we have to worry? But listen, methane is going to release. Now that methane is spread across the ocean water. If this is happening for near about 100 years, will that methane not trap the volcanic heat that is given? The volcanoes which are present within the ocean, there are more volcanoes in the ocean than on the land. Is it not going to trap? It traps. So that's the fear which we have. Not an immediate aspect that is going to happen. We are going to wait till hundreds and thousands of years. That's when. So 100 years are not too much. It's just 3 generations of human beings. Already, since 1750s industrial revolution, we have seen near about 8 generations. These 8 generations of people has changed the temperature, and today we are not in a position to live what they have lived. So like that, you go and mine, you leave every country will go and do the mining. Everyone wants the polymetallic nodules. Today, if I am able to speak, online students are able to see which mineral am I mined. I have mined a copper. There is a copper wire. ठीक है, there is a polymetallic nodule, nickel, cobalt. कैमरा में यूज किया जाता है. स्टेंसिल मेरा बोर्ड में है. This which is there. Internet cables which are laid across the globe. Yesterday I have shown you the internet cables, how they are laid. So with all of this, there is a minimal impact which we think we are doing, but in totality, we are going to impact a lot. So सस्टेनेबल माइनिंग करना चाहिए. देखो माइनिंग ज़रूरी है, ठीक है. how are we able to live this a comfortable life as compared to last 3 generations? They never had internet. Okay? They used to believe on a tota which has to fly all the way from another continent and it has to get a message, right? So that is a parrot they used to believe. They say that chalo, share the information. But today we have internet, right? So development भी जरूरी है, ये भी जरूरी है, लेकिन sustainable development जरूरी है. Mean, in simple terms, why does US has to own all the cables? It will just lay the cables and let's facilitate. If suppose climate change is happening to everyone. Today AC is there. In the AC, which gas is there? RC32, that is chlorofluorocarbon gas, which is there. Now this gas, everyone knows that if it is released into the atmosphere, it is going to go and deplete the ozone. Now today USA is having the technology to, instead of using this RC32 gas, they have hydrocarbon gases. Why is it that it is not giving the technology free to India? It is asking to pay. USA know that no, there's a climate change problem, which is ozone depletion is a problem. हाँ, क्योंकि US is a capitalistic society, it always wants to make even at the deathbed. ठीक है? Even, you see, even in today also I should not say this, any equipments which is related to the death and the funeral, 18% GST is there. You go to buy a tractor or you go to buy an helicopter, 5% GST. Any capitalistic tendencies will always would like to gain at the opportunity, and US best utilizes it. ठीक है? It is the best country. At every opportunity it will try to grab that, and they try to teach and preach you. So never should we in a position to take what is not good for India. Because there was a time in 1970s we did not have enough food to eat. We literally went with a begging bowl to the US and we asked, chalo, hame kana de do. You know what kind of food they gave to us? It is a very substandard food which is actually fed to the cattle there. But somehow we got and we accepted it. And we gave that food for 2 years to the people of the entire India. No nation across the globe came to us and said that, US, why are you giving this food to India? Only Russia then pointed out. ठीक है, बच्चे बच्चे को भी पता है ना, रशिया इंडिया का दोस्त कौन है? It says it is Russia, right? Yes. So it is always there, but nevertheless, you should not write your answers like this. We need to have a balanced opinion. But in times of interview, you can take a stand. You can take a stand that India's priorities comes first. ठीक है? When you become a foreign officer, India's stands are your first stands, no matter whatever the situation is the other countries. क्योंकि आपका अपना देश में लोग जो है ना, उनको खाना देना बहुत जरूरी है. चलो, now let's quickly move towards our next topic, that is your tides. Are you clear with this concept of waves? चलो, let's try to understand tides. किसी ने टाइड एक्सपीरियंस किया? Anyone who have that is, see, every 24 hours, any place on the earth will experience 2 high tides and 2 low tides. ठीक है? There are 2 high tides and 2 low tides every 24 hours. Any given place on the earth. Why? It is because tides are created because of the pull of the moon and pull of the sun. See, before I move any further, I need to explain the concept of gravity. Okay? Only then you will understand the concept of tides. For example, you have a bigger body mass which is called as sun. Sun is almost millions of, around 163 times the size of the earth. It is very, very big. Okay? If suppose this is the earth in this classroom, the size of the sun is the entire size of the classroom. That is the size of the sun. So sun's gravity, see, imagine this is your sun. The sun's gravity can have its impact till further distances. But you have a moon. What is the size of the moon? This बहुत छोटा है, जितना पैसिफिक ओशन जितना है, द साइज ऑफ द पैसिफिक ओशन. द इम्पैक्ट ऑफ मून्स ग्रेविटी इज ओनली टिल हियर. फर्स्ट थिंग, ग्रेविटी इज इन्फ्लुएंस्ड बाय साइज. Second one, see, you also need to understand the factor of distance. For example, let me take the earth. Imagine this is your earth. And earth has its own satellite called moon. Let's call this as moon. The distance between the earth and the moon is very less. Okay? But the distance between the sun and the moon, sun and the earth is very far. In a net factor, the gravity of the sun is very high. But there is also a factor called distance. Okay? Bale size of the object is very bigger, but if the other object is far away from it, then it may not have the same kind of gravity on that particular object. I mean to say, first suppose the distance from the sun to the earth is more, and the distance from the moon to the earth is less. This is near about 159 millions of kilometers, and this is just less than 1 million. So very large distance variation is there. Because of that, when you cumulatively calculate, the gravity that the earth is experienced, the gravity of the earth is experiencing the gravity of the moon more as compared to the gravity of the sun. Or in terms of, if 11 times the moon pulls the earth, then 5 times the sun pulls. Or in simple terms, if 16 is the total value, 11 comes from the moon and 5 comes from the sun. Now, who has more gravity pull on the earth? It is moon. Ye yaad rakhna, in spite of the size of the sun is very full. Yes, very good. Same concept. So in totality, it is moon's gravitational pull on the earth is more than the sun's right. Moon's gravitational pull is more on the earth. Moon's gravitational pull on the earth is more than the sun's gravitational pull on the earth. Right? So 11 is to 5. This is the ratio with respect to 16, the total pull that is there. Now for some times, let's look into the variation and the movements of the sun, moon and the earth. So you already know that. Look here. Look at this. This moon, what does it do? Moon also rotates and moon also revolves. This everyone know. Sometimes this moon can come here also. When it is in this position, what happens? Yes? Solar eclipse. What is solar eclipse? When the sun's rays is being blocked by the moon and the rays are not falling on the earth. This is called as solar eclipse. Solar eclipse, पिछले solar eclipse कब हुआ था? याद है आपको? Recently हुआ. But my question is, if every month if the moon is going around the sun and coming between the sun and the earth, don't you think that every month there should be a solar eclipse? Yes. कहाँ हो गई? Then every month there should be you should at least find one solar eclipse, no? But it is not like that, because the orbital plane is tilted at 5 degrees angle. That means if the moon rotates like this, then the earth rotates at this angle. ये कभी ना कभी उस मतलब once in a while this particular moon will come in the orbit of the earth. Suppose if this is your moon actually rotates at a particular angle. ठीक है? At a particular angle. Now this angle is tilted 5 degrees to the plane of the earth, because of which the moon will never come in a month. At least it takes few months together or maybe few years together to make an eclipse. Recently you got to see a solar eclipse, right? But no matter what, don't you think, how much time does the moon take to go around the earth? One full circle around the earth, how much time it takes? Revolve. अमावास्या पौर्णमी ये सुना होगा ना? Yes, that's what. Look here. This is the orbit of the moon and this is the orbit of the earth. Though they are not in the same line, that's why the moon will always not come between the sun and the earth. Only in few instances and occasions it will come. But you know that moon takes how many days to go around the earth? Revolution? ठीक है? Amavasya, Paurnami, that is what it is called, right? So, see, first suppose, let's consider this is your earth. Suppose this is your moon and this is your sun. A person is standing here. ठीक है? Will this be a new moon day or a full moon day? चलो, will this be an Amavasya or a Paurnami? चलो, शौर्य आंसर नहीं करेगा, बाकी लोग आंसर करेंगे. So, will this be an Amavasya? Is it a full moon day, or can you see the moon or can you not see the moon? Is this a full moon day or an Amavasya? What do you call it? Amavasya is nothing but new moon day. New moon means no moon. In Hindi, what do you call? Amavasya. ठीक है? In Telugu, Hindi, ठीक है, Sanskrit word है, Tamil भी same है. So, yes. ये दोनों अमावस्या कह रहे हैं, बाकी लोग क्यों? Very good. See here. If the sun is sending its rays, sun's rays will fall on this side. The sun's rays will be falling on the moon of this side. Actually, you see a dark side of the moon. This is the dark side of the moon. And this is the light side of the moon. In fact, this is what is your new moon. But let's imagine that how many days the moon takes to go around the earth? That is revolution, 28 days. It takes 28 days to come back to this position, right? After few days, if the moon is here, ठीक है? Moon can be here, right? Now, how much part of the moon can you see? 1/4, 1/8, half of the moon, full moon. Yes? One? Someone said 1/4. Again, I am going to take the moon here. ठीक है? How much percentage of the moon do you see? See here. Suppose if this person is located here, this person, the sun's rays will fall and reflect back. And this part of the moon, look, this part of the moon is the bright side and the other part of the moon is the dark side. Right? This is called as full moon. This is called as new moon. Moon do not have any light. Moon only reflects the sun's rays and then sends back. You might be having a question that, sir, अर्थ का shadow नहीं पड़ेगा क्या? अरे distance बहुत ज़्यादा है, board छोटा size है, so that's why I could not make a good diagram. But remember this, it is the sun's rays which is going and making them to fall here and it is reflecting. Now, can I say that in the same manner, look here, this is your full moon. This is your new moon, because you are able to see only the dark side is visible to you. Right? Now look here, the sun's rays will be falling on how much percentage? Look here, sun's rays will be covering this area. Right? And other half of the moon is dark. If you are standing this side and try to look this from the three-dimensional view, ठीक है? Area of illumination, that means the area of light of any celestial body is only 50%. You can only see 1/4 of the moon here. If you are standing here, how much percentage of the moon can you see? 25% here, 25%. This is 25% of the moon when it is visible to you. Now, how is this 25%? I think anyone have the doubt here? Why is this 25%? Everyone clear? Very good. So, only 25% of the moon you can see here, and this is called as the quarter moon. Now, from here to here, you are able to see 50% of the moon, and from here to here, again, you are going to reduce or increase. In fact, again, 25% of the moon you can see here, that is only this part of the moon can be seen, and it is moving towards no moon. Right? This is how the moon goes around. Now, with respect to the positions of the moon, look here, if the moon is here, moon will pull the water at this place. If the moon is here, moon will pull the water at this place. Right? In totality, the positions of the moon will decide what kind of tide you will have. Right? Kabhi suna hai, on a full moon day, please don't go towards the ocean. On a new moon day, please don't go towards the ocean. Amavasya hai Hajj, sea pe mat jana. It is fishermen, they don't go into the sea on a Amavasya. You know, it's a holiday to them. Why is that logic? Because your ocean is pitch dark and the tides will be very high on both. Why? Because, see, if suppose your sun, moon and earth, if they are in the straight line, sun, moon and earth, either like this or sun, earth and moon. What is this? Is this full moon or new moon? Case A, full moon or new moon? Amavasya. And this is? In either of the cases, sun is here, moon is here. both of them are trying to pull the water on the earth, they'll pull more, right? So let's try to understand this logic. See here, if this is your sun and this is your moon, sun is also pulling in this direction, moon is also pulling in this direction. Now why is that only water moving? Why not the solid? You see, earth is a beautiful entity. Earth has solid, earth also has liquid. This is a solid continent, this is a liquid continent. Now when this solid continent, can that pull the continent that is heavy, and the continent has molecules which are tightly packed and they cannot be pulled? But water molecules, they can be easily pulled, right? So water molecules which can be pulled, that's the reason why the water will be pulled like this. The water on this side will be pulled, and at this part of the place, if the moon is here and the sun is here, in this position which is called as syzygy. Okay? This is called as syzygy position. During the times of syzygy position, the tide's height will be very high. Or else, if suppose either, if the moon can be here also, even then this position, if the sun, moon and the earth are in a straight line, this position is called as syzygy. During the syzygy positions, the tide's height will be high, and this kind of tide is called as spring tide, right? And this also will have spring tide. I'll explain that. Okay? First, let's only consider this particular. Now, spring tide on which day is this? Full moon day or new moon day? Next, come to the new moon day. Imagine your moon is here, right? That means sun, earth and moon. Here also you will have a full high tide. This is called as the spring tide. And this spring tide is high tide. And this high tide is formed on new moon day. That means you will have two spring tides in a 28 days time period. Moon takes 28 days to go revolve around the earth, right? 28 days to revolution. Now, in totality, you have two spring tides in a span of 1 month, less than a month. There can be a position where this can be your sun and this can be your moon. That means moon can be here, right? Look, sun, the moon, it now came here. If the moon is here, especially at this particular place, what is the angle made? If the moon is here, angle made is 90. So instead of drawing here, I'll draw it the moon to be here. This is the angle made is 90. This is called as neap tide, right? So same way, the moon after few weeks, the moon can go here, and this is called as neap tide. That means you are going to have two spring tides and two neap tides in how many days? 28 days. Very good. Next. The interesting factor is, in a 24-hour time period, look here, earth is also rotating. Moon also revolves around the earth, rotates around the earth. Moon rotates and moon revolves. Today, आज शाम को जाके देख लेना. If suppose today, if you are able to see the moon at 7 p.m, tomorrow at the same place you will see the moon at what time? 7:52. And the next day, at the same place you will find the moon. See, moon you can see at various places, but at the same place I am asking, at what time you will see? After 52 minutes time gap. Every day there is a variation of 52 minutes time gap because moon moves little faster as compared to the earth. So there is a variation of 52 minutes that you get to see. That means in every 24 hours and 52 minutes you will see the moon at the same place again. कभी try करो, आपको समझ में आ जाएगा. And interesting aspect here is the earth is rotating. ठीक है? When the earth is rotating, earth will have a high tide here. First, suppose if your moon is here, ठीक है? Moon will start to pull this place. Here you will have high tide. But let's go to India here first of all and try to understand. Imagine this is India. Moon यहाँ पर है, right? This moon got a high tide at this place. How much time does the earth take to go around itself? 24 hours. Right? Now India, after 12 hours, where the India will be? Other side. Now look here. If the moon is here, don't you think as the earth rotates, at this particular place, whichever the place is coming, that place will be experiencing a high tide? I mean to say, imagine India was here at 7 p.m. ठीक है, let's imagine this is रात को 7 बज गया. India was here. The moon is here. At 12 p.m., at 12 a.m., where will India be? India will be somewhere here, right? But this particular place which is exposed to the moon will experience high tide. As the earth starts to rotate, each place on the earth will be experiencing a high tide because that is facing the moon, right? But at any given place on the earth, the earth will have two high tides. One high tide on this side, one high tide on the exactly 180 degree of that particular place. I mean to say, if you have a high tide at this place, then you will also have a high tide here. If this is your moon, this tide is called as gravitational tide. And this tide is called as inertial tide. Now, why do you have these two high tides? Because of the moon present here. See, for example, let's imagine there's a theory called a motion. Anything that is in motion will also experience something in reaction, or else equal and opposite reaction hota hai, or else inertial theory that is called. Have you ever experienced a fast moving bus? All of a sudden a bus driver has stopped, put a brake. What do? You go forward and then come backward, right? Anything in motion will be in its motion, right? So earth is considered to be in motion. Dekho, simply try to understand. Imagine earth is a bus which is going round and round and round. All of a sudden, moon came and put a brake on the water. There will be an opposite side, no? I hope you are able to understand this. This earth is rotating. All of a sudden, moon came and pulled some water here. A body which is in motion will also be in motion, right? You will experience that motion. So likewise, imagine this is a bus which is moving forward. All of a sudden, instead of brake, this moon has put a brake and pulled the water. Don't you think that the water as it is pulled will also be pulled on the other side? So this pull is called as an inertial pull. Because earth is continuously rotating and moon is trying to pull the water here. The moon pulled the water, but on the other side you will have equal and opposite reaction. And this reaction is called as inertia. And you need not go anything technical to understand what is an inertia. Inertia is nothing but when a body is in motion, will tend to be in motion in spite of you trying to stop it. The best example is your bus or any moving body, car. You tend to be in motion and you move forward and then come backward, right? So in similar manner, imagine this is 7 p.m. At 7 p.m. you'll have one high tide here and also high tide here. But the high tide on this side will be of little higher and the high tide here is of less high tide. right? Now, if the water tend to rise higher here, kahin na kahin on other place of the earth, there should be lowness in the water. So this water is actually pulled. All the water is getting pulled, right? It is pulling from where? It is basically pulling from the same ocean. In fact, if the oceans are well connected, the water gets pulled from this part of the places. Water is getting pulled in this direction, and you'll have high tide on every longitude. These are high tides. The water is getting pulled from both the sides, and the water is getting pulled in this direction. So don't you think that this part of the earth, where there you will find depression? Now this is the place where you will have low tide. That means if this is considered to be your low tide, यहाँ पे low tide होगा, and exactly on the opposite side of the earth you will also have low tide as a belt. That means water is pulled on either sides because of one inertia, other one is your tide. Now add sun to this. Imagine add sun to this. What happens? The tide is going to be more high tide. The high tide is going to be more high, and the low tide is going to be more low. Right? On a full moon day or else on a no moon day, the high tide is going to be very high and the low tide is going to be very low. Right? I hope you got this. On a new moon day also, the high tide is going to be high and the low tide is going to be low. Now all these are related with the positions of the moon and the sun. ऐसे भी हो सकता है. Actually there is a plane. This is a plane. In a different plane it can be anyway. In whichever the plane it is moving, in that plane it will create the high tides. That means, can I say that at any given point on the earth will experience two high tides, and on the opposite side of the earth also you have low tide. Two low tides and two high tides. Now you tell me, in 24 hours, how many high tides, how many low tides? Any place on the earth. Two high tides and two low tides. Right? But the biggest problem here is our oceans are not well connected with each other. Look at Pacific Ocean. It is a very big ocean. Right? And Indian Ocean, छोटा सा ocean है. And Atlantic Ocean, it is locked by the continents. Right? Try to look at this particular point. This is our ocean. That means the water is pulled on either sides. If suppose moon is here, sun is also here, the water is pulled at this place. Now from where is that the water of the low tide areas are going to get pulled? In the same ocean. ये ocean तो locked है ना? If the sun is here, moon is also here, both are trying to pull this ocean. That means maybe at this particular place you will have a high tide. But don't you think that the water from this areas will be pulled into the high tide area? Right? Now you will have a high tide here. And again you will have a low tide at this place. This is low tide area. This is low tide area. All this area will be low tide and this area will be high tide. So sometimes you might have two high tides and two low tides, two low tides and two high tides. It all depends on the local topography. But in general, when you look into our earth, will experience two high tides and two low tides at any given place on the earth. In simple terms, let's try to understand that India is 7, अभी तो 7 सुबह 7 बज रहा है. 7 a.m. At 7 a.m. India experienced a high tide. Now next high tide at what time India will experience? This is 7 a.m. सुबह 7 बजे you got to see a high tide. Now when will India experience the next high tide? चलो लो टाइड कब आएगा? देखो, see here. Just a minute. Let me explain you this concept. For example, if this is your earth, there's a person standing here and this person today saw the moon. ठीक है? Remember this very carefully. Try to understand this. This is the logic that you're going to understand. If suppose this person is able to see the moon, earth is rotating. Moon is also rotating and revolving. Earth is rotating and revolving. It is changing its position. Now for this person, today it is 7 p.m. For the same person to see the same moon at the same spot, this moon will be back the next day at 7:52 p.m. Now, how many hours are there in between 7 p.m. and 7:52 p.m.? 24 hours. Clear? 24 hours, 52 minutes. Why? Because Earth is also rotating and Moon is also rotating and Earth revolves. So that means there is a gap of 24 hours and 52 minutes to come back to the same position the Moon it is. Right? Now imagine, look at this place. Remember this Earth is rotating. Okay? Continuously it is rotating. If suppose the Moon is here and it faced this part of the Earth, will it have a high tide here? Yes. Equal and opposite reaction, you also have a high tide here. Right? Got it? Now, let's imagine our India is here. For our India to come back to the same position, how many hours it takes? On the earth I am talking. India to come back to the same position, how many hours it takes? 24 hours. Right? But to see the moon at the same place, how many hours it takes? 24 hours, 52 minutes. That means, when India is here, the moon is giving a high tide to India. But India came to this location. Will you have a high tide or low tide? Low tide. Again, India came to this position. High tide or low tide? High tide. India came to this particular position on the opposite side of the globe. Low tide. That means, you have a high tide here. You have a high tide here. Sorry, you have a low tide here. Then you have a high tide here. You have a low tide. That means, India at any given place is experiencing, in a 24 hours, 52 minutes time period, it is experiencing 2 high tides and 2 low tides. Are you clear with this? Now, see this. If suppose, for India to face back the moon again, it is 24 hours and 52 minutes. Divide by 4. How much? 24 hours and 52 minutes. Divide by 4. 4 ones are, 4 six are. Next, 4 ones are and 4 13s are. That means 6 hours and 13 minutes. Now, don't you think that if you have a high tide here at 7 p.m., after how many hours the same place will see a low tide? Six hours 13 minutes. If suppose this is your India, 6 hours 13 minutes के बाद India will experience a low tide. Again, you see, after when India comes to this place, here it will experience a high tide. India goes back. Let's imagine on the opposite direction. I am going to draw this India here. So here 6 hours. Again 13 minutes के बाद high tide. 6 hours 13 minutes. That means between a high tide and low tide, how much time we have? 6 hours and 13 minutes. आप बताओ, टाइम बताओ अभी. 7 बजे, 7 p.m. you got to see a high tide here. When will India experience another high tide? चलो, low tide is 7 plus 6. What is this low tide? Sorry, AM. ठीक है. Next, what is the low tide, high tide time? 7:26 AM. Now again, what is the high tide timing? 1:26. Yes, 1:39. AM or PM? AM yaar. No, PM. It is PM. Right? This is how the time calculations are given. That means between two high tides, how much time is there? Between two high tides? 12 hours, 26 minutes. So can I draw like this? Suppose this is low tide. This is high tide. Again, this is low tide. This is high tide. This is low tide. So imagine 6 hours and 13 minutes is the time gap. Here again 6 hours, 13 minutes. 6 hours, 13 minutes. 6 hours, 13 minutes. So 6, 6, 6, 6. Right? If 7 a.m., then let's make the calculations little easier. I'll call this as 12 a.m. मतलब रात को 12 बजे. What will be the high tide time? 6:13 a.m. Next here low tide time. Fast, calculate. 6:13. So 12:26. What? PM. Next, after 6 hours 13 minutes. 6:39. Next again, after 6 hours and 13 minutes. That means 12:52. How much? यहाँ से if the date is 21st here and this date is 22nd. What is today's date? 10 July, 12 a.m. पे if you have a high tide at one place, then 11th July at 12:52 a.m. you will have another high tide. Right? So just the logic is that 6 hours 13 minutes you need to remember. So examiner might ask you that if a place is experiencing a high tide at this time period, when will it experience a low tide? Now, examiner can say that all the places on the earth will experience at least 2 high tides and 2 low tides at a given place. ठीक है? It is not always true. It can be false because of the local topography. But ideally, a place should experience 2 high tides and 2 low tides. Right? Yes? हाँ, पुल तो कंटिन्यूअस कर रहा है, लेकिन कुछ ऐसे जगह पे ओशन ही नहीं है एशिया पर. The pull that is being experienced is always at 6 hours 13 minutes. पुल तो कंटिन्यूअस ही हो रहा है, बट देर आर सम फ्यू एरियाज, जैसे छोटा सी है. Sometimes sea might also experience a high tide. Right? Ideally, you need to have 6 hours and 13 minutes for each high tide and a low tide place. So today, what do we do is you go and Google it. What is the high tide time on Mumbai? ठीक है? You will get to know. High tide and low tide timings on Mumbai you see. Yes, moon भी तो move कर रहा है. That is the reason why it is not 24 hours. It is 24 hours 52 minutes we have taken. अर्थ से तेज मूव कर रहा है वो. So you can go and check today's high tide and low tide time for Mumbai. It is exactly the same times and all you will get to see. So this is how your tides are calculated, and this is one of the most important topic. Your tides are related with the positions of the sun and the moon. These positions can be studied like this. There are some names that are given. Simply, this is new moon. New moon se first half of the moon, this is called as waxing. Again, if it is going towards the full moon, it is called as waxing gibbous moon. From here, if it is going, it is called as waxing gibbous moon, and that is waning. Waning and waxing. So waxing means, is the size of the moon increasing or decreasing? The area, light which you get to see, it is waxing is towards increasing, and waning is towards decreasing. Waning means kam hona, waxing means बढ़ना, right? So a high tide and the spring tides, you will get to see it new moon and full moon. Now add sun component to it, up very greatly it will pull. This is the concept of tides, right? Spring tides are there, neap tides are there. Neap tides are 90-degree tides. It is also a high tide, but spring tides are more high tide. On any given day, you'll have a high tide, 2 high tides and 2 low tides at a single place. That is an ideal one, but due to local topographies, sometimes this can vary, right? In totality, this is your tides, and we are left with a concept called currents that we'll do tomorrow. हाँ, टाइड से पावर जनरेट हो सकता है. इंडिया में कहाँ पे कर रहा है ये? Where are we doing in India? There's only one place that the tides possibility is there. It's not West Bengal, it is what? Gujarat. जहाँ पे depth of the ocean थोड़ा ज़्यादा है, वहाँ पे tides can be more, right? Shallow oceans पे you will not get to see a good tides. Now, where do you find the best tides, biggest tides in the world? It is Hudson Bay. Now, where is this Hudson Bay? In Canada. ठीक है? Hudson Bay. This is the area where you will find a very, very big tide, very, very high tide. 14 meters high tide होता है. For suppose if we can tap the energy of these tides, we can generate electricity out of it, and India is trying in the state of Gujarat. So the potential of a high tide in India is less as compared to other countries. In spite of we having 7,000 plus kilometers of coastline, why is India not being able to tap the tidal energy in India? This can be the question. One, this you will learn in the further classes in little more detail. There are few places where you can tap, but countries like Canada and all, they can easily tap. It is because of their local beach topography. That high tides can be 14-15 meters also. It is, let me show you this as well. Bay of Fundy.